Alright, today, folks, we're going to talk about solving linear equations. I'm assuming you already know how to solve linear equations, but we're going to review some things to make sure we're all on the same page. First, you need to know what a linear equation is. A linear equation is anything that can be written in the form ax plus b set equal to 0. Now, we're not going to put things in the form of ax plus b set equal to 0, but if you can, it's a linear equation. A can't be 0, of course, and a and b are real numbers. Basically, it's if you can set it in this form and the degree of x is 1, the exponent of the x is understood to be 1, then you know it's a linear equation. When you're solving linear equations, as long as you do it to one side of the equation, you may do it to the other. When I say do it, I mean add, subtract, multiply, or divide. So you have to keep your equations balanced. So if I decide to add a number, whatever number, to one side of the equation, I also have to add it to the other side of the equation. You can subtract the same number from both sides of the equation. You can multiply the same number to both sides of the equation, and you can also divide the same number from both sides of the equation, as long as that number is not 0. So let's go through several examples just to refresh your memory on how to solve linear equations. The first example we're going to do is just the very basic kind. 5x plus 7 set equal to 27. I want to keep that 5x term together, and I'm going to keep it. I'm not going to do anything with that until the very end. So I'm going to try to deal with everything else first. In this case, there's only a plus 7. So in order to get that to the other side, as some of you like to call it, we're going to subtract 7 from both sides of the equation. Make sure you're doing it on opposite sides of the equal signs, not on the same side of the equal. So that you have 5x is equal to 20. Now I can deal with that x. Since that is 5 times x, just to get x by itself, I have to divide both sides by 5. And that will give me a coefficient of 1x. But we just like to write x. And so I end up with x is equal to 4. And I have my solution for my equation. Now, you can always check these by plugging x back in and making sure the equation is true. So we can always do a check. If I plug in 4 for x, I have 5 times 4 plus 7. And the question is, does that equal to 27? If it does, it checks out. So 5 times 4, of course, is 20, plus 7, and it does equal to 27. So you can always do a quick check on your equations. Let's work another example. I've got 3y plus 18 is equal to 7y minus 6. Now, I have two terms that contain y, and I have to get them on the same side of the equation. And I have two terms that are numbers. I'm going to get those numbers on the same side of the equation. So I'm going to choose to get the y's together first. I'm going to use addition and subtraction. I'm not going to use that multiplication division property until the last step. Okay? So I'm going to subtract 3y. Kind of going the opposite direction, but I like to keep my y's positive. It's the way I like to do things. So I'm going to move 3y over by subtracting it from both sides. That's going to leave me with 18 is equal to 4y minus 6. Now I have to get the numbers on the same side of the equation, so I'm going to add 6 to both sides to get that 4y term by itself, because I want to solve for y, and it has to be alone before I can solve for it. Now I have 4y is equal to 24. Now the very last step then is to get the y by itself, because that's what we're solving for. So I'm going to divide both sides by 4. And so I end up with y is equal to 6. Now, we can always check and make sure that's our solution. So I can plug it back into the original equation. I have 3 times 6 plus 18, and I want to know, does that equal to 7 times 6 minus 6? That gives me 18 plus 18, and that's 36. This gives me 42 minus 6, and that's also 36. They do equal, it checks out. So y equals 6 is the solution of our equation. And another example. This time I've got 13x plus 5 is equal to 2x plus 5. Very similar to the last one we did. We're going to get our x terms on one side, our other numbers on the other side, and then we'll solve. I'm going to subtract 2x from both sides first so that we get our x terms together. This leaves me with 11x plus 5 is equal to 5. Then I'm going to subtract 5 from both sides. That's going to leave me with 11x is equal to 0. And my last step is to divide both sides by 11 to isolate that x term. And so that's going to give me the answer. X is equal to 0 divided by 11. Well, that's 0. And then I can always check by plugging it back into the original equation. 13 times 0 plus 5. The question is, does that equal to 2 times 0 plus 5? And of course it does, because that's 0 plus 5. And then here I get 0 plus 5. And so we end up with 5 is 5. It is true, so x equals to 0 is the solution for our equation. It's okay to get an answer of 0. Students don't like the answer 0 sometimes. Let's look at another example. One with fractions. Now, these fractions have the same denominator, so really you could just work with the fractions and that would be fine. But I want to show you another way because it's going to be helpful for you this semester. You can get rid of the fraction by multiplying both sides of the equation by the least common denominator, the LCD. So that's the method I'm going to use to choose to solve this problem. The common denominator of the denominators is 3 because that's the only one we have. So I'm going to multiply both sides of the equation by 3. I'm going to multiply the left side of the equation by 3. And I'm going to multiply the right side of the equation by 3. So that when I do that, I have 3 times the quantity 2/3 x plus 1 is equal to 3 times the quantity 1/3 x minus 6. And then I'm going to apply the distributive property so that I have 3 times 2/3 3 times 2/3 x plus 3 times 1. I'm just going to go ahead and show you this step, show you that you have to multiply every single term by 3, equals to 3 times 1/3 x minus 3 times 6. Well, notice when you multiply 3 times 2/3, the nice thing about it is 3 divided by 3 is 1, so you're just left with 2x. Or you have 6x over 3, which you can also say is 2x. Plus 3 is equal to, here you just end up with x minus 18. And then I'm going to subtract x from both sides of the equation. And 2x minus x is going to give me x. Plus 3 is equal to negative 18. And last, I'm going to subtract 3 from both sides of the equation. And so I end up with the equation, or the answer rather, x is equal to negative 21. Just a couple of things about this particular problem. Multiplying fractions. Remember, when you multiply fractions, you always multiply top by top, bottom by bottom. So if you have A over B times C over D, it's going to be AC over BD. So if you have the number 4 times 3/8, well, that's equivalent to saying 4 over 1 times 3 over 8. And I like to reduce before I multiply. So I know that 4 and 8 will reduce to give me 1/2. And then you can multiply. 1 times 3 will give you 3. And 1 times 2 will give you 2. So remember to multiply top by top, bottom by bottom. Just a quick review of fractions. Now let's solve another equation. I have 5 times the quantity x plus 1 is equal to 3 times the quantity x plus 1 plus 2 times the quantity x plus 1. So the very first thing I'm going to have to do is get rid of the parentheses. I'm going to multiply the 5 times the quantity x plus 1, which means I have to apply the distributive property. I have to multiply the 5 times the x, plus I have to multiply the 5 times the 1. And I'll have to do it on the other side as well. I'm going to have to take 3 and multiply it by x, and then 3 and multiply it by 1, and that's going to give me 3x plus 3. And then I'm going to take that 2, and I'm going to multiply it by the x, and I'm also going to multiply it by the 1, and that's going to give me 2x plus 2. Before I move on to the next step, I want to combine like terms because there's too many things going on. So on this side I have 5x plus 5, and on this side when I combine my like terms I have 3x and 2x. They're like terms. That will give me 5x, and 3 plus 2, that will give me 5. Notice really I have the same thing on both sides. So when I go to try to finish this, I can subtract 5x from both sides. My x's just go away, and I end up with 5 equals to 5. I could subtract 5 from both sides and end up with 0 equal to 0, but it's not going to accomplish anything. I can't solve for x. But notice that both sides of the equation are equal. That kind of equation is called an identity equation. When you get the same solution on both sides of the equation. So anytime you solve for an equation and you end up with 0 equals to 0, 4 equals to 4, negative 2 equals to negative 2, that's what we're going to refer to as an identity equation. Now, if I solve and I end up with different numbers on both sides of the equation, for example, if I end up with 0 equal to 5, or I end up with 7 equal to 0, then that's going to be a contradiction. And then the last type of equation is going to be a conditional equation. A conditional equation is everything else we did today. So when I solve, for example, and I end up with x equal to 9, that's conditional. It's got one answer. So do the homework and Hawks.